Hi, everybody. Welcome to this Airside Chat. My name is Finley. I'm an aerospace engineer and I'm part of Safe Landing. We're a global community of aviation workers, students, and enthusiasts who care about the future of our industry and the future of our planet. So we're really keen to platform different companies that are doing something innovative in the world of zero carbon travel. I'm really excited to have Regent here today. We've got Estefie and we've got Adam, who are going to talk through a bit about what their company's doing and the vehicle that they're developing and testing. It's not an aircraft, but I would say it's kind of aviation adjacent. There's some of the technology that's in there has similarities to some of the stuff that we see in aviation. And it's a fully electric concept. So we've got stuff like electric motors and electric propellers and that kind of thing. And I think obviously when you're thinking about the future of flight, we need a bit of a sort of multimodal transport system that considers the full network of how we're going to travel around in the future. Um, so great to have Regent here to discuss that. And yeah, welcome to Estefie first. Thanks for joining today. How you doing?
Hi, nice to be here. I'm doing great. I'm Estefania Castillo. I am with the Regent Craft team. I am leading data analytics at Regent, working with Office of the CEO, with the sales team, with the defense team, really combining that engineering knowledge and transforming it into that front forward-facing content that we need to really sell this product. My background is in aerospace engineering and economics, and I've been with the company for almost 4 years. I've had the pleasure to see it grow from 20 people to over 100 now. Nice to be here.
Awesome. Well, yeah, thanks for being here. And yeah, looking forward to hearing a bit more about the technology. I see you've got your presentation up already, so I can let you take it away, talk us through a bit about what you're working on, and then we'll have a bit more of a discussion afterwards. So enough from me. I'll pass over to you.
Yeah, absolutely. So let's talk a little bit about Region. At Region, we're trying to solve the problem of regional transportation. The problem when you're traveling a short enough route that taking a flight is a little too inconvenient because you have to go to the airport, you're spending time going through security, and then on the plane, planing, deplaning, all that adds up. But it's too long to drive. And nowadays, you're stuck in traffic almost regardless of what time you leave. So that's why we're building a Seaglider. We're trying to combine the high speed and comfortable travel experience of the airplane travel with the certification and the infrastructure availability of the maritime world. And doing all of this bundled in a fully electric vehicle that adds the benefit of it being zero emissions. Um, an example of a route that could many people could be familiar with is in LA in California in the US, going from LA to San Diego. It's only 100 miles or 160 kilometers, and it might take you up to 2 hours with traffic, even upwards of that. And if you decide to fly it, let's say it's going to be $200 to fly, but you'll be stuck at the airport. Instead, you can take a sea glider, get there in 45 minutes for a ticket price of as low as $60 and skip the whole hassle. You drive to your nearest port instead of driving to your nearest airport, and you get to a downtown San Diego. When we look at the vehicle that we're building a 12 passenger vehicle that's called Viceroy, 100% electric with a range of 180 miles or 300 kilometers, and a cruise speed of 300 kilometers per hour. Now, some of the key distinguishing technologies that enable this travel is our hydrofoils combined with our flight controls, combined with electric propulsion, because wing and ground effect craft are not new to the world, but we're combining these technologies in a novel way to allow us to really unlock the potential of low speed takeoffs that then allow us to go on to wing and have high wave tolerance. So I want to take a step back and talk about how do sea gliders operate. Sea gliders are a boat. We start off in the dock just like a boat. We float through busy harbors up to speeds of 23 miles per hour or 20 knots. Then we rise onto hydrofoils, which are underwater wings, and we travel up to 50 knots on these hydrofoils. This allows us to give us that wave tolerance and allow us to get up to speed to be able to then take off and transition into flying. So once we're in flight mode, we can go to that max speed of 160 knots or the 300 kilometers per hour that I was talking about and travel to our destination where we'll land and again dock on a dock. Seagliders are boats, therefore we only operate over water. And we are always within one wingspan of the water. So we're always within 10 to 20 meters from the water surface. The controls for Seagliders are super simple. Seagliders are captained by mariners, and the controls are very intuitive. It's just left, right, fast, and slow. Pitch control, cruise, altitude control is all controlled by our automated flight controls. And yeah, this really opens the labor market to, you don't need to be a pilot to captain our Seagliders. And we're building our Seagliders with that multi-use capability in mind. We want to enable our customers to be able to achieve whatever mission they need to achieve. So that often means commercial, cargo, offshore logistics, special missions. And we also carry this design philosophy into our interiors. We keep our interiors versatile and allow for different interior configurations.
Oh, I just want that was fun.
Now we really see that Seagliders are going to be part of this multimodal future where we are going to be one piece of the puzzle combined with the eVTOLs, the trains, the CTOLs, and we're just going to plug in to make the most sense for the short regional travel that's exclusively coastal, right? Now, talking a little bit about our customers. Our sales team has gone out and secured firm orders and strategic investment across 6 continents. We have customers through the aviation industry, the ferry industry, offshore logistics. We're really seeing adoption across different regions and across different industries. Here you see a couple of the logos that stick out. We have total orders for over 600 vehicles, 410 Viceroys, 225 Monarchs, and yeah, we're really seeing a lot of traction here. Now, because we're a brand new product, we understand that we need more than just sales. It's a brand new product. We need the market to also adopt this product. So that's why our team has gone out to develop what we call ecosystems. So when we develop an ecosystem, we get together and build a group of corporate, government, and corporate entities and community entities to bring them all together and work on understanding in their region what are the key pain points and then what are the key benefits of bringing Seagliders to market there. That's our effort to work hand in hand with our customers to make sure that the market where they want to operate, we are priming that market, understanding it thoroughly, and being able to prime it so that when the time comes for them to receive delivery of a Seaglider, they're able to integrate it seamlessly into their locations. And we've created ecosystems in Hawaii, Florida, the UAE, Rhode Island, Brazil. Really like where there's interest for a Seaglider, we go out and work with our customers. Now, when we talk a little bit about what is the Seaglider we're building a family of products. I've talked a little bit about the Viceroy, which is our 12-passenger vehicle. The Viceroy is being prototyped in Rhode Island at the moment, and it's that 180 miles or 300-kilometer range. Then our next generation vehicle is going to be our Monarch Seaglider. So that's going to be a 100-passenger vehicle with entry into service in 2030 and operational range of 400 miles or upwards of 600 kilometers. What else? So the other thing I want to touch on is infrastructure availability. I talked a little bit about how we're combining that aviation world with the maritime infrastructure. So Seagliders dock on docks, right? They dock on the water, and you can see here how similar this setup looks to what we're greatly familiar with, right? It's a finger dock on a pier, and there's just very few things that we need to consider adjusting for. We need to consider adjusting for the wing clearance and for the hydrofoil clearance. But other than that, a charger and a finger dock, and we're ready to go. And we have a setup very similar to this right now in Rhode Island, where the company is based. Um, and that's where we're docking our prototype Seaglider. And yeah, and that's a little bit about Regent. I'm happy to take questions and pass it on to Adam.
Thank you. Yeah, well, I guess I've got a few questions to kick things off, and maybe either of you could answer. But yeah, I mean, firstly, it's quite yeah. I personally, for me, it's quite incredible what you guys are working on. Just it looks like the future, doesn't it? Like looking through some of the presentations. So it's a really interesting, um, unique vehicle, and yeah, really exciting to see it getting tested. And looks like there's quite a few different technologies going on with your vehicle. So I think maybe just the first thing is I'm aware that there is a bit of a history with this type of aircraft, right? I think Russia quite a few decades ago had these things called the plans that were kind of like this, but like big with jet engines. Yeah, the legacy vehicles in the top left there. So those are like lots of jet engines, which I guess are really expensive, not particularly efficient. So even though the concept like could deliver efficiency in a way, like I guess it'd be really expensive and quite difficult to do. And my guess is that like the development of electric motors and batteries has meant that we can unlock the kind of thing that you're working on in a way that's kind of not been possible before. So is it possible just to talk a little bit more about how like electric power can kind of enable what you're doing and how it's different to some of those previous attempts that have come before?
I can take this. Appreciate the question. Yeah, so why hasn't this been done again until now? So the Soviet Akronoplans were amazing machines, 300-ton weapons of war. To your point, you can see those 8 jet engines, 4 aside at the front of the vessel there. Those were required to sort of drag the vessel through the heavy surf and develop enough speed to break the suction of the wing against the water surface. So the challenge with the chronoplans were that they were not particularly wave tolerant because you're dragging the vessel through those heavy waves. You need low waves to get airborne. The second challenge is they were very controller intensive. So you had to be a pilot, even if they weren't certified as aircraft, you had to be a pilot to hold the vessel in ground effect. So I don't know how many pilots are on the call, but flying low level is challenging. Flying low level for extended periods of time in ground effect is very challenging. So the chronoplans, required quite a bit of interface by the operator. So we solved the wave tolerance challenge using hydrofoils. So hydrofoils are just a wing for the water. So as you accelerate that fluid over the top of the foil, there's a pressure differential. The vessel elevates up and out of the water, and that dramatically reduces the hydrodynamic drag while dramatically increasing the wave tolerance of the vessel. So because of that design, we can use a deep V hull, which also gives us some additional wave tolerance. And then once we're on our hydrofoil, we can maneuver just like any other hydrofoiling boat. So the hydrofoils have control surfaces on them that allows us to yank, bank, pitch, roll, all the things you would do, in a boat or in an airplane, using the water as an interface. But the next major unlock is the distributed propulsion and advanced battery technology. So using distributed propulsion, we can and electrical power, we can take multiple electric motors and run them along the leading edge of the wing and actually blow the wing. So in blowing the wing, we make the wing think it's going faster than it actually is. And that's how we get our takeoff speed down to about 45 knots with this vessel. So for those seaplane operators out there, you'll know that you probably need to be up around 70 to 85 knots with flaps extended to get airborne on a seaplane. Meanwhile, your passengers are kind of getting bounced around the whole time while you're getting up to those speeds. With Seagliders, we can rotate at about 45 knots. Once airborne, the hydrofoil retracts and we cruise just like any other turboprop. But that blown wing, the hydrofoil, the deep V hull, and then the fly-by-wire flight control system are all massive differentiators, right? So this vessel is envelope protected, just like an ERJ or a Airbus. So you can't stall it. The takeoffs and landings are all automated. So the vessel is, flight condition or foil condition is controlled as a function of the thrust lever position. So as we advance the thrust lever through the foil gate and into the flight gate, the vessel automatically accelerates, and then when reaching an appropriate speed, takes off. As long as you're in the fly gate on the thrust lever, you're going to fly. When you're ready to slow down, just like you would in any other boat, you'd pull the thrust lever back. If you go past the first stop and into the foil gate, it will automatically touch down, decelerate, and then transition back up onto foils to match the speed you're requesting with the thrust lever. So it's really all of the latest technologies that make this viable today. But really, end of day, people don't want to get on something that's not comfortable to ride on. And the wave tolerance really makes the ultimate difference in why this is commercially viable with our design versus previous designs.
Oh, yeah, thank you for such a comprehensive answer. So like that that hydrofoil that's in the water, once you get above a certain speed and you've left out of the water, there's like an automated system that retracts those, and then when you slow down and they sort of automatically um, pop out again. And yeah, and it just
Exactly.
on that, because I guess if just thinking about like it's sort of a little bit equivalent to on a boat having the keel, but I see it's like a T shape. Is that for increased stability when it's in that mode?
Yeah, so it's you do get keel effect, so for those twin engine pilots out there, understanding how having your landing gear extended gives you more stability with the keel effect associated with having an engine out. So there is a small keel effect associated with the hydrofoil, but you can see we have this big, huge box tail on the back of the vessel. That gives us all the surface area, pitch and roll authority we could ever ask for, associated with a vehicle of this size. So look at the massive T-tail you see on the chronoplane in that picture. Imagine taking that, just sort of cutting it into squares and boxing it out so it takes up less space, and then putting it on the back of our vehicle. So we've got plenty of rudder authority associated with this. So the T on the hydrofoil gives us pitch and roll control when we're in the water. So that's its only function. And it also, the T is what provides the lift. So the strut on the foil, I guess theoretically it could provide lift when it's being actuated, but only the rudder is actually turning vertically. So that T is the foil, and that's what provides all the lift for when you're in the water to get the boat up and out of the waves.
Thank you. Okay, so just thinking about so there's some really good slides in there showing basically how this would leave from a conventional port, and I guess might have a number of these at a specific jetty. How do you sort of envisage the future of these being used? Because you also had some sort of and I guess maybe just a bit related, like maybe some of the use cases you think are like the most promising early adopters of this technology, because you had some good, interesting clusters around the world. And it was there was like Hawaii and there's Japan and sort of island nations that have various smaller islands off them. So you kind of imagine that you'd maybe arrive somewhere like Hawaii to the airport, but then there would then be a transfer to the port, and then that could then take you like around the edge of the island or to another island nearby, that kind of thing. And is it sort of maybe a little bit like replacing ferries, but also like smaller flights that might do that sort of thing at the moment?
Yeah, so there's about 5 use cases for the vessel that we've identified. They track very, very closely with what you would use a turboprop Cessna Grand Caravan or de Havilland Twin Otter for. So similar use cases, just dramatically increased wave tolerance versus a traditional seaplane. So passenger transportation is obviously our bread and butter. So ferry companies, small airlines, hotels, all interested in moving people in innovative ways. We also do tourism. So a number of our operators are interested in touring around islands to sort of showcase, the space and beauty of their particular region. There is a dedicated logistics application. So whether it's middle mile, offshore logistics, we've got deals with Total and ADNOC. We have deals with a major offshore wind service provider. These are ways of moving, more personnel and equipment more quickly to these locations. There is a VIP mission. So imagine this being somewhere between a Phenom 300 and a Challenger. This is a very big interior, 6 feet tall, 5.5 feet wide, cargo door standards, lots of room in the back. So that gives us a lot of optionality for VIP configurations. The primary one is a double club with a side-facing seat that also doubles as a potty. Finally, the last mission configuration is the special mission configuration. So we can do, CASEVAC, MEDEVAC. We can do special mission, ISR. We can do maritime patrol, and sort of everything in between. So we have an optional rolling door that allows you to deploy, all types of different, life rafts or life-saving equipment to people stranded. So a number of potential applications, but those 5 are the primary on the commercial side. And then there's another 6 available on the defense side. We are a dual use company. We work closely with the United States Marine Corps on a number of potential applications around CASEVAC, MEDEVAC, around launched effects, around ISR and submarine patrol and others. Quite a bit you can do with this platform.
Yeah, a lot of applications. Okay, and I guess maybe this is a bit of an obvious question, but I guess keen to make kind of the case for, like the economic benefits of developing this kind of technology. What would you describe as like, if a particular country were like in America, you're developing this, what would be the kind of the economic case you make for it, both in terms of like the manufacturing capability, but also just like being the first to operate this and the kind of jobs and work that could come out of this for workers?
Yeah, well, first and foremost, because we cost about 30% less, 30 to 40% less to operate than an equivalent turboprop, yet we carry about 1,000 pounds more payload. You can provide all of those downstream efficiencies to your customers. So what that translates to is lower ticket prices for the people that need this kind of platform to get to high-paying jobs, to access affordable housing, to move on their daily commute. What this does is it allows people to transit without using the 4 primary modes they're traveling on today. So you don't have to go to an airport to get on this thing. You can just go down to your local dock and board. You don't have to sit on congested freeways and wait in traffic. You don't have to make multiple stops on rail. And then you don't have to take the slow-moving maritime platforms that are currently serving these routes. So you're really combining the best of aviation and maritime and wrapping it in a very high-tech product that because of its low operating costs, provides a number of potential benefits. So, these vessels are going to be built in the United States and in Abu Dhabi. That's the 2 manufacturing sites that have been identified. But because we've sold these vessels to 6 continents, around the world, you can see a number of potential applications. And a lot of that is, again, driven by the fact that there's very, very low infrastructure required. You really just need to get the charging down to the dock. We operate out of existing docks today. So you don't have to build a vertiport. You don't have to carve out valuable space at your airport, right? Like, the idea that these big, huge international airports are going to take, super valuable ramp space to park eVTOLs, to charge, to seat 3 people and take off and land. I just don't find that very likely. So, the more you can leverage existing infrastructure to do new things for more people, the more likely you'll see adoption of your platform in the future.
Nice. I'm just thinking a little bit close to home for me. I'm in Scotland and we've got Ireland just across the water, but it can take quite a long time for me just to to get the ferry across. And then firstly, the ferry isn't actually that low carbon because it runs on big diesel generators and you've got to wait for all of the cars and all of the lorries and everything else to go on. So it can take most of the day to get there, even though you can almost see it across the water. So yeah, that's quite exciting for improving that connection. So yeah, well, just when thinking about this from like a government perspective, so if there was a government that was like, this is a brilliant idea, we really want to encourage this sort of thing, we want to accelerate what these guys are doing, provide that good ecosystem, and to try and get some of the first sort of trials and testing, but also maybe prove the first routes. What sort of support do you kind of look for from governments or things that can really help you do that?
Yeah, so right now we prioritize all of our ecosystem development efforts around the regions and spaces where our customers will take delivery of their vessels. So we are a pure play OEM. We're just like an Airbus or a Boeing. We just build these boats, and then our clients actually take delivery of them and provide a service using the platform. But to answer your question, those customers work closely with local, if it applies, state or provincial government and federal government to unlock specific routes. So they identify, with the team's help. Estefi leads our data analytics team. So they're like an in-house McKinsey. They provide all the necessary analysis to help a CEO and board of directors make an intelligent decision around vessel purchase. And then with that information, we assemble a group of critical stakeholders. And those critical stakeholders are from the utility, they're from local, state, and federal government, they're from community groups and potential customer bases. So we pull everybody together and we say, okay, what's required to provide service between the following harbors? What considerations need to be made around wildlife, around charging infrastructure? So we really try to pursue a big tent policy where we're making sure that each of the critical stakeholders have a chance to have their voice heard, so that when our operators do set up service, that they're not, operating through, community prized places or culturally sensitive areas or places where manatee are mating or sea turtles are laying eggs. So we try to be very, very conscious of the space. But as you would imagine, every single ecosystem has its unique set of hot buttons, and it really gets to the dock by dock, route by route level, and you just build. I see Raquel has a question too. Just in case.
Yeah, I can let you jump in, Raquel.
Yeah. Hi, thank you. Thank you for this very interesting presentation. I wonder about the certification process. I understand it's not an aircraft, but because of that flying phase, did you have to involve FAA a lot at all, or is this just certified? Just certified as a sea vessel, and which I guess simplifies things.
Yeah. That's a great question. So under IMO for the past 30 years, Type A WIGs or wing and ground effect vessels have been classified as boats. So there's more than 30 years of IMO precedent and regulatory guidance, supporting the certification pathway. So we have two pathways domestically in the United States. We're working with the United States Coast Guard. They evaluated design basis agreement, engage in construction survey, and sea trials to certify individual vessels. We follow a very, very similar process with equal rigor under Lloyd's Register for all of our international deliveries. So that's Lloyd's is one of 4 or 5 major class societies around the world. There is space where the maritime authorities can pull in subject matter experts, from partner regulators, in the event that they lack understanding of one particular system or another. But all of our regulators have made clear that, their ownership, falls under maritime, and that's the way, they'll be moving ahead.
Okay, thank you.
Yeah.
Just I suppose extension of that, have you found when you do then talk to the regulators, because the vessel is quite different from, I guess, the ones they're used to working on, that they have sort of been like, well, we might need to like work out a new form of compliance, and kind of like working to develop the kind of certification standard to sit alongside this, because it's quite like a new field.
Yeah, actually, I mean, that's where one of the big benefits of the IMO comes in. They actually created all of the regulatory guidance for certifying wing and ground effect vessels, as I said, almost 30 years ago. So there's quite a bit of material out there already, helping maritime regulators understand how wing and ground effect vessels work, how they're classified, what's the process for evaluating them and making sure that they're safe for commercial use. So we've been in the process of building off that, and then obviously, to be successful in this space, you have to have a very close working relationship with the regulator. Helping them understand the systems on board, the standards to which you're making them safe and preparing for operations. So we've been working closely with Coast Guard, with Bureau Veritas, another classification society, with Lloyd's Register for 4.5 years now. So there are no surprises here.
Nice. Well, yeah, final question from me, and then I'll stop recording. I know there's see a few people with hands up as well. Just any advice really, for we've got aviation workers and students, and those could be engineering students or people looking to get into sort of sustainable transport. What would be your advice for sort of getting into the zero carbon travel industry, and sustainable transport?
I'll let Steffi answer that one, because she's by far been the most successful most recently at making that happen. So go ahead, Steffi.
Yeah, I mean, I think part of it is just awareness and knowledge of what's out there. I think we're lucky enough to live in a time where there's an insane amount of developing happening in the world, and oftentimes it's a matter of going and finding out what those companies are, where they're located. I surprise myself all the time finding new exciting companies around the world. Um, Especially in the aviation space, there's a ton of advanced air mobility, regional air mobility, all these acronyms that exist out there, and it just goes to show the amount of opportunity there is, and it's up and coming. So yeah, I mean, my piece of advice would be stay up to date, read the news, join the email lists that could maybe give you nuggets of information of where to look. Um, and yeah, I mean, Regen is just one in an ocean of many companies, and I'm sure we'll see a lot of success coming up in the sustainability and maritime world.
Thank you. Cool. Well, let me just.
I would echo that. The only thing I would add to it is I would just say, follow your passions. If you're interested in aviation and advanced air mobility, to Steffi's point, there's a lot of businesses out there. I would worry less about where you get on and more about just getting on, because your unique skill sets and experience will immediately be seen as valuable in this space. So I think the most important thing is to just get on board and then figure out a way to maneuver within the business once you're there, because all of these companies are growing quickly.
Thank you. And thanks for chucking a little bit of aviation terminology in there as well, getting on board and maneuvering around. So yeah, thanks both of you, Estefia and Adam, for that.